So first and foremost, thank you very much, everybody out there, for joining. This is the first ever Power Hour. So this is presented by PowerHour Insulation. My name is Dan Edelman. I'm all about collaboration and education. I have many contacts out there, builders, architects, contractors everywhere in the country. And what the plan is for today is really working and engaging with architects and builders on this panel, going over different discussion points, different building science practices, and really just learning more on different climate zones around the country and understanding what makes things differently. This first one, we're actually just doing the four control layers. So really more of a fundamentals of building science, get everybody on board, understanding what we're going to be talking about. These are going to be every single month for the next very long time. So I also worked with at Rockwell Insulation. That's Roxel. That's where many of you guys actually know me from, and they're continuing to do those as well over there. But I'm going to be continuing with these. So we have. I'm going to go through kind of the guests. As they kind of appear on the screen, and then do like kind of a quick introduction. So yes, I've been in the mineral wool business for about 13 years now. And then actually went over to a manufacturer of screws. So now fastening is also something that I'm very knowledgeable about, with different thermal conductivity of different fasteners and all that fun stuff, fun geeky stuff. So I'm a big giant building science dork. And I hope that everybody out there is appreciating this, because this is supposed to be a fun but engaged kind of conversation. And I'm going to start with Chris Lomer Giddens. So, Chris, tell us a little bit about yourself and where you're from, not the Eiffel Tower.
Yeah, Chris with LG Squared from the Southeast. I'm in Atlanta, Georgia. We are a firm that we design, build, and consult all over the country. We have off-grid projects, passive house. We have a presence online as well, educating and sharing what we have learned and the mistakes we've made and mistakes other people have made. But we're all about education and also building better.
Awesome. And thanks for joining us once, or thanks for joining for the first time ever, Chris.
Of course.
Next, we have Walt Tamala.
Hey everybody, Walt Tamala, owner of TNT General Contracting, build, design, educate firm based out of Westfield, Massachusetts. 33 years in business, started it right out of high school. Yeah, I mean, building practices and best building practices are what we teach and what we're constantly striving to teach others on. We have a focus on trade schools, and we have 5 co-op students and apprentices within our program right now. So anybody out there that's listening, if you're not involved with your trade schools, take a little bit of time to meet some of these young folks, because this industry really needs them, and they're ready to learn, and they're ready to jump in with both with everything, and make a good go at this. So trade schools have really changed from where they used to be. But happy to be here with PowerWool and PowerHour and all my friends. So Dan, thanks for having me on. Appreciate it.
Thanks for seeing you for the first time on this, Walt. Next, we have Randy Rand.
Yeah, so thanks for having me, Dan. This is great. I'm Randy Rand, owner of our Haas Builders up in Orono, Maine, and also member and trainer for Passive House Maine, which is where I'm at today. We're holding a 2-day high performance for builders training. So it's exciting that we're in a new space and actually have a dedicated facility for builders, architects, designers, all to utilize differently. And even manufacturers can come in and hold events here and invite people to utilize the space for anything in the built environment. And we hope to just grow and share our knowledge with the general public. So it's a great opportunity for that. But I've been in the built environment for like 20 years, started in the architectural engineering field, with always a focus on indoor air quality, comfort, durability types of things. And it's just always led me down pathways of high performance and ultimately passive house as kind of a standard where we build. But yeah, that's the basics.
Well, awesome, and always good to see you, Randy.
You as well.
And then this is a collaborative approach, the Power Hour. So we also have Paige Sherwood. She's going to be fielding all the questions. So please, as we're going through, add to the chat, or not into the chat, but into the question box at the top corner of your screen, if it's like my screen. If it's in the chat, feel free to talk amongst yourselves, coffee talk. But for the question side, if there is any questions out there, Paige will then kind of pop on, ask the question, real time. We want to make this more, of an event for you guys as well, and really being engaging with you guys as well. So obviously after the fact, you guys all have my email address if you received the emails for this. So you could just reply right back to that email and you'll get right in touch with me, and then we could work with you and our technical team. And then last but certainly not least, we have Paige Sherwood. And I'll let her do a quick introduction too.
All right. Thanks, Dan. Yeah, so I'm Paige Sherwood. There might be a few of you who knew me by my maiden name, which is Paige Malloy, because I've been working with Dan now for, gosh, I mean, it feels like forever, but it's only yesterday.
12 years.
I have a background in mineral wool. I worked for Roxel. Then I did some WRBs and envelope sealing, weatherization work. I also worked at Timber HP with wood fibers. So for me, insulation and the building envelope is the name of the game. I am, I guess, a juvenile building science nerd. I know enough to be pretty dangerous, but definitely enough to get excited about stuff and what we're doing here today. So what Dan said is I will be turning off my camera while the gentlemen here discuss different things and go about what they plan to do. When I get a good question that needs to be presented, they know, or maybe they're familiar with, I will turn my camera on, and that is the signal to stop. There's something that we need to answer. So it runs kind of smoothly, and you can raise your hand or laugh when I just kind of show my camera and they get a little discombobulated because now they know they need to stop. We're here to make it fun. We're here to have fun. So yeah, I obviously work with PowerHour Installation. I'm the Northeast Regional Manager. If you have Dan's email and need to get a hold of me, feel free to put it in the chat and I'll make a note to reach out to you privately. And other than that, let's have a powerful hour. Is that what we're doing?
Nice.
I like it.
Do it. So today, so first I'm actually going to kind of get started of the story of PowerHour. I know many of you guys out there, really it's a brand new brand. It's a mineral wool based product. But really the story is actually it's Ross Power. He's a third generation owner in the Power family, serving really only the Western Canada. So it's a building material supplier that was out there. You could see the Power lumber in that top right corner. So that was basically the original lumberyard that they owned and operated out there. Then kind of fast forward to 2016, and really there began to be shortages, especially in Western Canada, for mineral insulation. So that's when PowerHour actually became an entity in Western Canada. Then again, fast forward to 2021, and PowerHour started stretching across the US border, mostly because the very long lead times. You remember COVID back then, and it was just very difficult. I was with Rockwell at the time, and yeah, lead times were very, very long. So they started distributing into the US market, started growing, and in 2025, they basically said, hey, we're really doing well in the US market. Let's really start driving demand. So we began stocking in 3 US warehouses. So we have very low lead times, typically under a week, maybe up to 2 weeks, depending on where you are in the country. Walt Tamala just placed his order on Monday, and he should have it by hopefully tomorrow, because I'm going to be at his project on Monday to help install it and get some video. But so very short lead time, and that's for our Rigiboard product, which we'll also get into real quick. But the big thing that really drew me into was really the contractor feedback, talking to people like Walt. He's already used the product. We had another contractor out in Salt Lake City, a big commercial contractor, who was using our cavity board product, and it holds together nicely. It's more rigid than the competition, and it's still the great, fire, water, all that product that you came to love. So we're really just a new supplier in the mineral wool space, and really there for, you know, the service is what we really kind of strive upon. And then mineral wool, the beginning, this is a story I always love to tell because it actually was discovered in nature. So discovered in Hawaii. The native Hawaiians would actually find these strands of fiber that were basically when the volcanoes would erupt and the hot lava would flow over the mountainsides, the high winds would actually carry across them and would whip up these strands of fiber. And the natives would call it the hair of Pele, or the hair of their god. And they actually were taking these fibers and using them as a building material on their huts. They realized early on that it was fire resistant, because when the embers from the next volcano would erupt, it wouldn't catch their huts on fire. And then it was also a really good insulator. It's just simply volcanic rock, basalt, the entire Earth's crust. And then all that we do now, I'm not raking the sides of the cliffs in Hawaii, although that would be a fun weekend activity. We basically just take the basalt, which is, again, the entire Earth's crust, and recycled steel slag, the byproduct from the steel industry, and we melt it at 2,700 degrees Fahrenheit, so it does take some energy to use. But then we whip it into fibers with the big giant cotton candy machine. That's kind of the best way to explain it. Then we add a little bit of binder just to hold it all together. We cut it and pack it into PowerHour bags. So that's kind of the way that it's made today. But mineral wool in general has been on the market for about 100 years now. I'm sure any remodelers out there, you guys have definitely seen that come through. So, or have seen old mineral wool in the walls. Building Science 101. So first, I wanted to kind of start going around the room. You know, I'll start with you, Walt, just because you're the next one over here. You know, Building Science 101, like, what's a super easy concept? Like, what's Building Science 101 to you, or what's this image kind of showing?
Yeah, I mean, for us, it's like, what are we dealing with certain temperatures and climate zones? You know, if it's summer outside and we have hot, humid temperatures and conditions outside, what are we doing to keep it controlled so our climate zone inside the building is comfortable for us to be living in? And, you know, we're going to need our control layers in order to do that. We're worried about, you know, our bulk water. We're worried about our vapor drive. We're worried about airflow. We're worried about all of those. And that's why these 4 layers are going to be so important. But you know, I'm up in Massachusetts, so we get all 4 seasons. And those changes really impact how we build and how we think of our assemblies. So in the winter, it's cold and dry out. And, you know, you're running, depending on what your heating system is and such, you could be really warm and moist air inside. All of you out there can relate to just shower situations and everything of that nature, and waking up with condensation on windows and such. So the reality is, we then have to focus on how do we protect the inside from the drive outward, because all of the warm air, warm conditions want to move from warm to cold. So you're going to see that in different climate zones, we need to use our control layers in different fashions and assemble them properly.
Awesome. Thank you, Walt.
Yeah.
Randy, hit it.
You guys just stepped in.
Well, really, honestly, I look at this and I'm like, man, I don't want to live inside. So I don't want the same environment I mean, I don't want to live outside. So I don't want that outdoor environment in my house, right? And so we've got to figure out how to keep it out, and how to have a good, comfortable space to live in, which is where we want to spend our time. So, and obviously, building science is super important in understanding that, so we don't actually create an unhealthy space to live in. So, yeah.
So Building Science 101 is a spin-off of the movie 101 Dalmatians.
How many spots can we find on these houses?
Spots can we find in the house? Those are the failures, right? You know, building science it's about control, you know, and for those of us in this industry, we like to call ourselves control freaks, because we are controlling as much as we possibly can for the best, most durable, timeless structure that does not kill our clients. it's about the indoor air quality. It's about every component from inside to outside of that structure. It's the science of our buildings. It's the building physics. So you cannot beat physics. Physics happens whether you like it or not, and it will catch up to you. So building science is the understanding of that building physics, of the physics of building, and creating spaces, creating buildings that will last a long time and will be healthy and comfortable and beautiful forever.
Awesome. Yeah. And I put up a couple things on the side also, just like warm moves to cold. When somebody says they're actually getting cold, they're actually just a reduction of heat. So that's all that really is. So you always, and this works in a commercial building or a residential building. When I get into some of these, offices, and it's like, well, we're not designing residential builds, we're designing commercial builds. Well, physics aren't any different between the building, unless it's a refrigerated building, for meat storage or other things like that. Then it can be actually quite different. Or a hot yoga studio like Chris did.
Hot yoga, that's right. Right next door to a wine cooler.
Yep.
On the other side of the wall. It's the physics of that are simple, right? Yeah, super simple.
Yeah.
That's building science 1001 right there.
Exactly.
What happens when you bring the two of those together, though, and you're doing hot yoga with wine?
Happiness is inevitable.
All right.
Yeah.
We're all signing up for yoga classes.
Absolutely.
And well, I know this is very easy for you, but you could just go through all 4 control layers if you know them all.
Sure. I mean, there's only 4, so Dan, if I miss them, then I got some issues after this long in the industry. But we learn something new every day. So we have our water, we have our air, we have our vapor, and we have our thermal.
And you got them all in the right order.
See, look at me, I've been practicing.
Well, wait, that was my next question, guys. Hold on.
Answer the punchline. All right.
So what is the correct order for them? What's the most important control layer?
Randy, that one's all you, buddy. Come on.
For me, it's air. I go with air as number 1.
So you're okay with a wet, tight building?
Well, bulk water obviously is the first thing I look at, but when I'm thinking about these, it tends to be air is the one thing that we focus the most on.
Yeah, I mean, water. What's the 3 leading causes of building failure are water, water, and water. And what air does is it brings in moisture. So it's all about air carrying moisture, air carrying heat, heat carries moisture, and moisture carries heat. Excuse me. So air is going to be the primary over vapor. It's like infinitely greater transport of moisture than diffusion is. And then thermal, it's fine. We like it, but you get air right, and you can go a long, long way after water. So there you go.
Yeah.
And Dan, may I add the other control layers to this as well, as just a sidebar? Dan, there we go. We got fire, we got bugs, and we got beauty. We have to control the aesthetics. As our friend Joe likes to say, ugliness is not sustainable. So we have to control those as well.
Well, and I think there's actually another missing control layer that now is more prevalent than ever.
UV?
Nope.
Hit me.
Yeah. Hit us.
Fire.
Yeah.
What?
Is it? Yeah.
Fire.
I said fire.
Oh, you said fire? I'm sorry.
You were playing your PlayStation. It's fine. Let's go.
Paige, what do you got for us?
All right.
So
Paige.
we have from our friend James, what is an upcoming control layer soon to include WFRB, wildfire resistance barrier?
There it is. Fire.
Do you want to touch on that, you think? Any brands associated with that? Any info to put into the whole control layer or where that would fall?
Well, it would definitely be on the outside under the cladding with continuous mineral wool insulation. So PowerWool, Ridgy board, or cavity board would be perfect products for that control layer.
And your cladding, you know, all the components
And
from the
cladding.
cladding, yeah, from everything from outside to, I mean,
Two
or
sheathings.
yeah, to your sheathing. I mean, your sheathing can be a fire control layer. You can have. We built a house, a whole homestead up in Western North Carolina, right in the middle of fire country up there, and it was
Hmm.
literally not a single component of that structure like this, basically like what's shown in this diagram. It was steel studs. We had sheetrock. I mean, we had rock for sheathing on the inside and the outside, and then we had stone. We had 8 inches of stone wool. We had hat channels made of steel, and then steel cladding, corrugated steel cladding. You can have every layer be a fire control layer, but
Correct.
to start from
Yeah.
the outside does protect if you have a wood structure. And this material, mineral wool, is an approved, code approved fire stop. So there you go. It does not get to your wood, your interior, unless it's what, 2,500 degrees, roughly.
2,150 degrees. At that point, it melts into hot lava.
There you
You
go.
don't want to be there.
Nobody will be there.
So my next question is, sorry, Paige.
I was gonna say we got a few questions just fired
Yeah,
back to back.
perfect.
Cool.
I guess they wanted to see my face. So, is there ever any talks about acoustics being added to one of the control layers?
That
Yeah.
definitely could be depending on the project. I mean, that's where I think also mineral or power wool does come in.
Mhm.
Just because, I always say density and mass is one of the most important attributes for controlling sound. A 4-inch concrete wall is really quite nice, but you're not going to build a 4-inch concrete wall for many different reasons, ease, cost, many different things. But by utilizing power wool, especially on the exterior, and as we're building houses closer and closer together, you have a lot of these fire and sound concerns as well, and they're kind of combined. But even using, there's other methods as well, and not a white noise machine on the inside. That's, to me, not an adamant way of doing
Yeah.
it. Like, so.
And these control layers that we talk about, and I added the 3, and we talking about other control layers for sure. But these are the layers that a building needs to deal with the conditions every single day, every minute of every hour of every day. This is the stuff that it's like. Yes, there's a fire once in a while. There's there are bugs sometimes. So
Mhm.
these are the ones that have to do with the building enclosure, dealing with the weather conditions that are inevitable everywhere, every day of the every day. So that's what this is all based on, not how many things can we control. Well, this list would go on forever, right?
Right.
To that person's question, I think if you live near a train station with railroad tracks behind you, or you're in flight path for an airport, like
Sure.
we are over here, we have an Air Force base right next to us. And I got to tell you, we've done more outbound insulation for the last 15 years at renovations on these
Mm.
houses, just to give some kind of a soundproofing and a control layer for that. But yeah, it's all about location and what what impacts that house we're building. But yes, like Chris just said, these 4 layers impact every structure that we build.
Where
And
Walt is right now in the mountains there, sound isn't much of an issue. You kind of want that to come in.
Yeah, I mean,
Right.
I've always said these control layers is really all about comfort and durability. So when you start thinking about it that way, then obviously sound is a comfort thing as well. So they actually
Mhm.
tied in there's a study about decibels inside of a space and stress levels,
Yeah.
and that's a real thing. So definitely great question. And then Randy, I'm going to start with you because you're in the furthest
Hey,
north.
what page does she have another question?
Oh, I'm sorry. Yeah.
Um, I do actually. Sorry, they all started streaming in and we're navigating chat versus questions right now. So teaching moments on many levels, good things. Um, Okay, so this one's a little lengthier, so get ready. Working on a FIAS project that has designed 8 inches of power wall below grade, but also up our stem wall about 2 feet. Trying to come up with a system to adhere to the stem wall above grade, short of expensive long tap kongs. Maybe adhesive. Maybe the next day after we remove form drill and glue stainless all thread or something else.
Wow.
I'm assuming this is exterior,
So
right?
can we actually, I know Reed, thank you for that. I was going to
Yeah.
get to that one at the end because yeah, that's something that he's working on in a current warehouse. We're going to get to that one actually at the end in the Q&A section. But yeah, we're gonna keep going on the control layers though, but we'll
Okay.
discuss that one. I did bring it up to Chris at his project when I was down there in Atlanta. So Randy, where would you put the different control layers in your climate zone 6?
So we're trying to do as much as we can to the exterior of our walls. So obviously our water control layer is our cladding for the most part, our bulk water, our roof, our drainage systems around the house. And then with our thermal, we're trying to get at least 1/3 of our thermal to the exterior too. And the more, the better, to keep our, sheathing warm as possible. So that's our goal here. And then depending where our sheathing winds up is where we're usually doing our air control layer. We like to keep it to the outside rather than relying something inside like drywall or an additional layer inside for our air control. It's just much simpler. And then vapor. Vapor is kind of like one of the last things we consider. So it all depends on what we ultimately do. But most of the time, we're controlling vapor on the outside from getting into our walls. We're controlling it on the inside, getting into our walls, but trying to figure out a way that we're going to allow our wall assemblies to dry if they need to. So we're trying to remain as vapor open as possible.
Awesome. And that's probably very similar to you, Walt, in Climate Zone 5.
Yeah, spot on. That's exactly what we do.
Awesome. And then how about in the South, like Climate Zone 3, Climate Zone 2 even, Chris?
Put them all under the slab. All of them. Just put them all down there so we don't see them. Cram them down. So there's no difference. I don't care. It doesn't matter where you are in the world. Control layers belong on the outside of your structure. And one thing that does, especially the air barrier, air control must happen to the outside. It is the most difficult thing to install and complete an air barrier on the inside of your structure. And then you have exposed a component of your structure to the outside by not putting it on the outside. But one confusion I just take this chance to clear up here is with the thermal control layer. So we have this assembly in that we use 2 inches of stone wool on the exterior, and then we fill up a 2x6 or a 2x4 wall with stone wool bat, or not stone, or stone wool bats, sure, or blown in stone wool. And we have, without the cavity insulation, we have our control layer. So what that thermal control layer is doing is warming the sheathing layer, and that's it. That's the main one. That's not it, but it's the main thing we're trying to, by putting the control layer to the outside. So we have accomplished that with the right amount of insulation on the outside. We've warmed that sheathing so we don't have any condensation. Anything you do in the cavity is not part of your thermal control layer. It's additional thermal resistance, but it's not your thermal control. It's very important to understand that, so people don't think we've got this thermal control layer going in and out of our assembly.
Correct, 100%. Then what is each controller? We keep talking about these, but what are they? And I'm going to bring up the thermal control first because you can see the picture of this is Chris's passive house down in Atlanta, Georgia right now. But the thermal
You see through those windows?
is the power.
No, this is an airtight building, Randy.
There are no windows. The best window is a wall.
That's right. So that's what we're doing.
But how about the water control?
It's not there yet. We have.
No, what are, yeah,
What's that?
like
Oh.
different materials? What are the materials that we're talking about when we're talking about water control?
Yeah, I mean, we're talking about our
Settings.
roofing, our siding, our bulk water management, gutter systems and such that are on to direct, heavy flows of water. Anything that you see from the street that is on the structure is doing a bulk water control on the outside of that house, if it was done right, and hopefully it is.
Oh, right. You never tuck your snow boots into, or your snow pants into your boots.
Occasionally, well, at least once. We've all done it once.
You've done it once. Yeah.
Yeah.
Learn from your mistakes.
Good on the
How
hot.
about air control? What are some of the materials that we're using for this?
Plywood, sheathing, membranes, a lot of different options.
It's a
Yeah.
Something you can't blow air through.
Right. Yeah.
something.
Even
Well,
concrete
that also
is an air control.
lets vapor go through it. Yeah, but yeah, I mean, it's got to stop air, and fluid applied is a preferred method for for us, because it is a more forgiving application for the installer. It allows you to achieve near perfection, or perfection in our case, with the use by using a painter, but in standard methods, standard tools, and not we're not we don't criticize other methods. We use them too, but they're doing it through the use of fluid applied gives us a lot more tighter tolerances of control.
Yeah, in our markets, we haven't seen a lot of that residentially. However, commercially, they've been doing it forever. And it seems like it may be something that, may start to make that transition into some of the residential market.
I think that's a joy of like these webinars and everything else, is because I've reached out to Chris as well, and I'm like, fluid applied, talk to me more about it. Like all the different systems that I've seen out there, you got to be certified in, and I hear that your painter's putting this on and rolling it on, and that there is a spray system, and I'm like, well, then you start talking about like, what's the concern if you start spraying this stuff, you get winds, and now you covered your neighbor's house with it. So it's just all things as a builder when we're thinking, hey, is this the right product for me? There's a ton of different great products out there that all these manufacturers have designed. It's really making sure that you've got the team that knows how to apply it properly, and that you're comfortable with. So, even as we're talking about PowerHour here, if you haven't tried it, it's one of those things that after hearing us, hopefully you'll understand that, one, it's not scary. It's really easy to work with. And as long as you understand how the system's applied, and you do it right, it's going to work well.
Well, haven't you ever learned how to not spit into the wind?
No, that one I tried a few times.
You don't spray into the wind. You don't spit into the wind.
Yeah, I've learned not to ride my bicycle with an ice cream cone on a hot summer day. It's a big mess.
Big mess.
But then how about vapor control? I think this always gets to be an interesting one. Because I feel like in different climates, vapor control actually means different things.
Hot side, hot, yes. No, it's always in the same spot. You have vapor control also in, on the hot side of your wall, right? You want to have, but yeah, like in Florida, you need a vapor throttle, right? And then here in the Southeast, or, a little bit further north, we have vapor open all the way up to the Northeast or to the north, and they need a vapor throttle on the inside. You gotta make sure. So it does move. You still need vapor control on the outside with the air barrier anywhere in the world. It's just it's the permeance and that really determines it, and and location in some parts of the world.
And I think that was more what I was sorry, Randy.
No, I was just going to say, and one of the best vapor controls is air control, right? As we kind of alluded to in the beginning, right?
Yeah.
We go from air moving a lot of water to relying on diffusion, and so.
It's the best air. It's the best moisture control. Yeah, yeah. Vapor diffusion is far less harmful than moisture moved by air.
And guys, I haven't used it yet, but question is, have either of you, any of you, used the multi kind of faceted products that are out there now that if the drive is coming from inside to outside, it opens to the outside.
Smart
And
converter.
smart, yes, exactly. Does anybody use those?
Yes.
Okay.
Yes. They're good air. Yeah.
No.
Go ahead, Randy.
No, I was curious how you seemed hesitant in your yes, but
Oh yeah. No. I just that it's still is it as smart as it says it is? There's just a lot of research and there's still some time that we need to let this diffuse in the market. But it's it's a good use. It is used a lot as just an air barrier because it has that vapor diffusion ability to diffuse and close up when you don't want the vapor to escape or to go in a different direction. So you have the like I've seen it used as insulation netting in an attic because I like to see a six-sided encapsulation of air control. But if you're in a conditioned attic and you're not finishing the ceiling, you can see this as an air barrier. But you have to know your assembly. You have to know the whole assembly has to work. You have to have the right conditions in the attic. It has to be fully air conditioned. You want to just really understand what you're doing before you use it. But yeah, they can come in handy. They're used a lot in double stud walls, where you need the control in the middle rather than on the outside or the middle on the inside.
Yeah, and a lot of those aren't really even. I mean, I think they call them responsive vapor throttles or vapor control in the code book now. But really, it's just relative humidity. It's simple, I think, wet cup, dry cup permeance ratings. So when the relative humidity increases, then they actually increase in permeance. So similar to plywood, not really on OSB, but yeah. So you guys have all seen issues with why do we need water control? What are some of the big issues that you see water causes? So durability of structure, obviously, that's a big one. Mold, indoor air quality, and then just complaints from occupants. Obviously, if their house is falling down, that's normally going to cause a complaint.
yeah,
And then, everybody kind of knows that, but why air control? Why is air control such a big thing? What issues do you see?
Go ahead. Anyone? I feel like
you're ready to talk. We're so like tuned
Oh,
into
I
you.
just
We're
don't
so
want.
excited to hear what Chris is going to say.
Well, you see this image is a really good illustration of what happens when air is not controlled. You're bringing in contaminants from the outside, and that darkness there is not normal. You should not just, people go to attic, they say, oh yeah, well that's just a building over time. That's just what happens with the insulation. It's not. That's dirt. That's air coming in from outside, passing this insulation sort of acting as a filter. It's bringing in moisture. It's bringing in toxins. It's bringing in sound. And we're trying that, those are the things we're trying to control and keep out. And air, this is why we keep harping on this air thing after bulk water, because it carries so many things with it, and it allows the inside conditions to get out of the building. So air leakage, all that stuff you want inside escapes, and all the stuff you don't want inside gets in. So it's all through air transport. And that's why that's why we encourage people to drive towards a zero air leakage, because you want a full control of the quality and quantity of air that comes in and out of your house. And this is a great example of what, and through air leakage, you can also get bugs. People in the South understand that one.
Yep. Well, I always call this the cigarette filter effect, because you could have, and this normally caused from light density vapor permeable bat insulation. And that's one of the things that why PowerHour really is more focused on the exterior building envelope. We only make the exterior mineral wool products because when you start having that kind of density, you know, the old who was it? Peter Yost, I think, is the one that says, like, you know, check its air tightness by just sticking your lips up on it and try to blow through it. You know, you get a piece of Ridgy board, first of all, probably not the most comfortable thing to do. And we don't recommend doing that, but you're probably not going to feel any air movement going through it as well. So, but that's where you have some of these. That's why they need to be incorporated with a proper air control layer as well. Otherwise, you're going to get this cigarette effect.
So I had a question. I don't know how many times I've been asked this, but today was one of them, and it was about, you know, what's the right insulation in a cavity? Is BAT better than that SPF thing? That F word? Is it better than stone wool? Is it better? What is the best insulation in a cavity if we're trying to prevent mold and this and that? I said, if you have a perfectly airtight cavity and the insulation is installed correctly, all of it works. So all of it works. Even foam, even bats, when it's installed the way it's supposed to be installed, 6-side, it's touching all 6 sides with no gaps, no air movement, convective looping, none of this, then it's going to work as it's supposed to. So it doesn't matter. It's not the product there. It's the system. It's the install. It's that incorporate. So that's where getting to near perfection and fire tightness comes in handy.
100%. Yeah, the guys from RDH Building Science, they're a great resource for you too. A lot of great white papers, but they even brought up about using continuous insulation on an airtight building and how, you know, you could put leaves, you can go back to using newspaper as your cavity insulation because it really doesn't make a difference, because when you start using that continuous insulation, it's really putting a lot less strain, and you're airtight, a lot less strain on that cavity insulation as well. And you could have now a lower cost total wall assembly by using, I always like using vapor open fire resistant insulation on the outside myself. So, but yeah, another actually a little comment came in also. A big part is wasting energy and oversizing mechanicals as well, which I definitely agree with.
Which is the cause of the heat loss
Right.
and heat gain through air. Yeah.
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 So why thermal control? Well, it increases thermal resistance of the wall. It's best on the outside. You know, this is something actually next month the PowerHour is going to be traveling over to Austin, Texas at the Build Show Studios. So more on that in a little bit. But we'll get through all that. But really the big thing is it's reducing thermal bridging. And our good friend Chris Lammer-Giddens here actually grew up under a thermal bridge.
I was
And
born under a thermal bridge.
so, and then why vapor control? You know, and I think this differs as well, because I feel like if you're warming the sheathing, you don't really have this issue that you're seeing right here.
Yeah, I mean, we've all seen that scenario, right? At least once, if not multiple times in remodels and such. And you're just like, where's this coming from and why is it happening? And I can tell you, after doing years of roofing and such, it was always, oh, well, you know what? It's condensation, it's this, it's that. There's not enough airflow in the cavity, or soffits are blocked. And vapor is going to get to where it's going to go if we do not protect, or we don't eliminate it in some way, shape, or form with a control layer. Again, when we're putting the mineral PowerHour on our exteriors, we're going from footing all the way up to roof and then over the top of it. So like Chris is asking and suggesting is the 6 points of contact and everything else, 6-sided, I should say. It makes all the difference in the world. And then we don't see this terrible mold and failure on our sheathing that you're seeing right there.
100%.
Randy?
And then, well, we kind of already kind of addressed this, but, you know, where do we need the control layers? Anybody?
Everywhere.
everywhere. Yeah.
Except for the South.
Chris doesn't need anything down there.
No thermal control, only air control.
Yeah. Bug control. That's all we care about.
Yeah. So one thing that I always like bringing up too, because we're talking vapor barriers a little more, and we're actually going to be having an AIA just on vapor barriers, or if you really need them. The big thing really is, I try to eliminate that word from my vocabulary, barriers, other than under a slab in your home or building. You don't want those ground gases coming up. That's the only place that you do a class 1 vapor barrier. And that's really your sheet polyurethane, your sheet metal, and non-perforate aluminum foil as well. So those are the things that I personally try to stay away from when I'm looking at different applications, except for below a slab. You can get away with these materials in different builds, but you need to be very, very smart about that entire assembly detail. Typically sorry.
Please.
Oh, and then my rule of thumb is always trying to get to that class 3 vapor barrier in the northern climates. This is really just more for climate zone 5 and north, maybe climate zone 4 as well. And if you look at the code, to get to that, it all includes a ventilated cladding, aka rain screen in today's terms, and that really dissipates a lot of that, or continuous insulation. And your air tightness layer is all outbound, so you're airtight. And then Randy, tell me a little bit about this chart. This is another chart from RDH Building Science that I always refer to when talking about vapor permeate. Oh, he's on the smallest screen.
Oh, no.
I was trying to see the numbers, but
So this basically shows when talking about exterior insulation and vapor permeance. When you start looking at these different products, the red is basically when they're a vapor barrier. So true to, vapor barrier under 1 perm. So
yeah, I mean,
basically,
yeah, one of our biggest things is always trying to obviously stay in that green area. We've had a lot of instances where there's been a lot of exterior insulation done with some of these vapor barriers, and what we're doing is we're trapping a lot of moisture in behind that product, and it's not necessarily from like vapor permeance, but it's the ability for that area to dry with like a bulk water leak, like around decks and ledgers and doors, and where they're just sandwiching these products on both sides of sills and everything like that. So we get a lot of inability to dry and a lot of failure to our actual structures and finishes into the interior because of these types of things. So
well, that was one of the biggest issues, I believe, with EFIS and with the EPS foam, not enough continuous on the outside, and then you get water, especially around the windows that were not flashed properly, and it would go behind there, and then it had no chance of drying out. And that's where mineral wool is actually something that you can put stucco right on. We do like dimple mats and air spaces outbound, just for, especially in the south. But even in the northern climates, it's always a good thing. But even like the Stows and Dryvits of the world as well, it's a good product to use with the vapor permeance of mineral wool. And then Chris, it's all you.
Oh
We're
Lord.
getting to the end of the
Look at that.
hour.
Those are some beautiful details. Yeah, it's continuity.
Tell us a little bit about that.
Yeah, yes. We're looking at the left images there. Those are images we use to help understand. We try to, whether we're talking online or we're on a job site, we try to really help people get to a point where they understand this continuity thing, and that every single system is acting the same way. It has all these control layers, and the most important thing is this continuity. And if you have one break in this continuity, you have failure. And then it becomes just an enclosure. And then even that is not, can also not be enclosing, because you're missing that. You have a break. The upper right is, well, the perfect wall is these are all the control layers in the right order on the outside of your building, and then you have the enclosure here. And then up in the upper right, this is the section of the Atlanta Craftsman Passive House. That's the picture in the bottom right. This is one of the first versions we did. We have ventilation on top of the insulation on the roof. We've now shifted to removing those 2x4s and letting that sheathing just sit right on top of the insulation. But the point is that that insulation layer continues up the wall and then to the roof perfectly, and then all around the ridge. And then the rafter tails are attached after. So we build the box and add the stuff because we want the overhangs for shading. We want it for the craftsman style that this house will be. These are heavy timber 4x8s. And so it's monopoly framing, it's Catan framing, call it what you want. It's a way to build a box, get it perfect, and then you attach these overhangs rather than let them penetrate your perfect layers that you've built. And so here you can see this is showing a cutaway of, there's your wall assembly full of blown in stone wool, and then you have your sheathing. We use CDX here, and then we have our air and vapor control layer. There, that's liquid applied on the wall, and then it's a peel and stick on the wall, on the roof, and then our 4 inches of stone wool, and then our rafters are they're buried in there. They're flush with the insulation. We put another layer of plywood, and then we have any old underlayment will do, and then we put any kind of roofing on top of that. So that underlayment does not need to be vapor. It doesn't matter as long as it's an underlayment. It can be 15, 30-pound felt. That's fine. This does come with a vapor diffusion port at the ridge. It's important to know when you need a vapor diffusion port. In our case, we're doing it as a belt and suspenders. We have a conditioned attic. We don't technically we don't need it because the building is perfectly tight and we're conditioning the attic, but it's there as a backup for when something happens that's stupid and causes an increased amount of moisture in the attic. It has a way to get up, or vapor, excuse me.
So all this rafters and stuff is like the bling for your bedazzling your envelope.
That's exactly what it is. Yeah.
And you did similar on your house too, with 8 inches because of the climate zone, but you also did the 2x4s on top because, again, climate zone 6 needs that vented. There's ways of constructing it so you don't, but that involves typically a very low perm product on the roof, sheathing, and on top. You went with the vapor open assembly.
Yeah, so we strapped the top of the stone wool insulation and then had an 1.5 inch ventilated channel below our sheathing. So, yep.
Yeah.
Are you in a WUI zone or any kind of fire prone area?
No, none. So we have a big benefit there.
Yeah.
This is one of the reasons going to this method here. We're in Atlanta. The trees are all stopping wet because we get 70 inches of rain per year. So we're not too worried about forest fires. Neighbor fires, yes, maybe. But mostly for California, this is a really good detail. And you might even have, this is a good way to not have to do the ember attic, soffit vents and things like that. But that's one of the reasons why we're starting to see more of this getting away from that furring on top of the insulation. So we don't. Yeah.
So
and
Chris,
I think for that, sorry, Walt.
No, go ahead. So Chris, how long have you been doing this type of a build and assembly for your wall
Before
system?
before it was called monopoly framing.
That's
No, I
how
mean,
long.
many people have been doing it for a long time. And just like the perfect wall was just a name given to a concept, and monopoly framing, same thing. But we have been doing it. I think our first one was in the early 2010s, so 15 years or so. And it was basically the same thing. It was the liquid applied. In that first one, we did 4 inches of stone wool on the wall and 7 inches on the roof, but no cavity insulation. So we literally put everything to the outside. So
And
I would like to call it stone simple framing.
whoa.
all right. Stone simple.
So Randy, when you did yours, what were the thought processes as you're thinking through them of the challenges you were going to have to do that monopoly framing? You did what I've done in the past is the 2x4 on the flats, so we have the airflow. Um, but like, how much longer did it take you to engineer and work through that process? Because obviously you're teaching your team to do things a little bit differently, but
Yeah, so we've done a couple different things. In the case that we did it here, it was actually a retrofit. So it was an easier approach than doing anything else because we could just chop off overhangs, you know, make it continuous, and then just apply that insulation on that existing roof deck, right? So it made it super simple. And I'm always a proponent of ventilating it. So the hard part always was the attachment method of that strapping, right? In our benefit, what we did on the inside is the existing structure wasn't, we were going from a site manufactured truss and then to a cathedral ceiling. So we actually had to sister in a support on the inside. So rather than trying to hit an inch and a half spot, we were actually hitting 3 inches. So we had a better chance of, you know, nailing those fasteners down through. So I felt a lot better about that in this situation. Um, we are working on another project similar right now where we are actually horizontally strapping the lower layer with a 2x4 on flat and then going over it and then doing another top layer. And now we have a much larger fastening area to hit, and we don't have to worry too much about nailing that inch and a half space again too. So multiple layers when we're getting to that thickness, I think, is a huge benefit and allows you to do a lot of different things.
Does this have an overhang?
This currently does, yes.
Okay.
Awesome.
So that 2x4 on the flat is your overhang?
Yeah, it's the overhang. You end up putting a nailer against the wall too, adding a sistered 2x6 into that, and then the fascia, right? Yeah, so there's more to it than just the
Yeah,
2x4 on flat.
it's not doing this. Yeah.
Right, exactly.
And then you don't also have like a 14-inch overhang
Right.
fascia. No.
And you want to make sure that like your first layer of plywood, you're doing things where you're going to increase that stiffness in that too. So your first layer of plywood's not split, you know, you get a full 4-foot sheet,
Right.
and you know, things like that.
Right.
So
Real quick, Dan, I wanted to just make a quick point on this. If you go back a slide, this is a big question for us is like, what about that ventilation? I mean, our current GC is asking this question.
Mhm.
Why don't we have that? Like, what about overheating of the roofing? That overheating of the roofing happens when you're on a hot roof, meaning your attic gets to 140 to 160 degrees sometimes down here. When the sheathing goes to the insulation like this, we basically call it a cold roof condition. So your sheathing is no longer 140 or 150 degrees. So your overheating and the problems you have with the roofing material don't no longer exist because it's up against that insulation layer. So we're not needing that gap to keep things cool. And plus with like standing seam metal roof, you have of course a little bit of a channel under there and there's some movement of air. But if you can test it, test it out and try and see what the temperature is of that sheathing. But remember that all came from when you have an unvented attic or a vented attic and you're getting those hot temperatures in the summer that cause those issues with your roofing. So just something for people that worry about that overheating thing and say, I gotta have ventilation, otherwise it's gonna overheat. Nope, not necessarily.
Yeah. And we're going to get into more in future power hours about just hitting one application, because I think that's a big kind of conversation points. I did want to bring up for next month, May 20th, and we actually have James Bourget in the chat or in the audience today from RDH Building Science. So he is an awesome guy. up in Western Canada, but he's doing a lot with us with fire and a lot of other building science. So he's going to be on the Power Hour next month, May 20th. We're going to go into the Build Show studios, me, Matt Reisinger, and James. So stay tuned if you're going to be getting all the emails and all that, or probably just 1 or 2 emails on that, how to register for that. But then I did want to bring in Paige again. So thanks, Paige. Were there any more live Q&As?
Not really. There was a lot of really good conversation pieces that came up in the question chat because there seems to be an issue with the actual chat section. The attendees might not have had access to that.
Oh, okay.
Which is okay. It's a first
Reed's
one.
question I did want to bring up.
Oh, then jump on that one.
Yeah, so basically what he has is 8 inches of power wool below grade, and where it comes above grade, how do you finish that off and how do you fasten it? I brought up about fasteners, but I know that there's some adhesives that are actually good for like roofing application. I'm just not sure if they'd be good for this sidewall application too, for where meat comes above grade. And then finishing with like a stucco.
How much does it come above grade?
Probably about 1 foot, let's say.
Well protected.
Yeah.
Like above it.
Yeah. Is it well protected there, Dan? Do you know?
That I'm not sure about.
Well, if you have,
how do you finish that so it just looks not like,
And then what's like? Does the insulation continue?
No, the insulation above goes to a 4-inch timber HP product.
So it steps back.
Yeah.
Oops.
Okay. Well, we've covered that with an a painted aluminum.
You just attach it into the structure.
Yeah. Well, the way we did it was this was continuous. It was that 4-inch, the house with the 4 inches, and the insulation went below grade, and so part of the aluminum went below grade, and then it went up behind the furring strips. So we attached the aluminum through the furring strips, so it was held up above the cladding. So it was just an black aluminum trim that went around the base of the building. So it's part of the architecture. But the issue I have with stucco or any kind of near grade is just the moisture and the splash, things like that. Whereas aluminum can be cleaned pretty easily. So I like the aluminum if you can't do a masonry or something to cover it. If that's not the architecture of it, I feel like aluminum has been a really sturdy, or copper.
Yeah. How would you attach that all the way back up to the wood structure?
If you're doing this, if you have a step like that, you can form the aluminum to go up behind the cladding, and then I assume there's some furring strips that hold on the timber, the wood fiber.
I would assume, yeah.
So behind the 1x4 is the furring. You can tuck that metal up there and just screw through the furring strips and then through the metal and into the structure. Just like your normal attachment of the furring strips, you just time it so that the metal goes on over the insulation before you attach your furring strips, or save the last screw for when you're putting that in.
Right. And then how about sorry, Randy. Oh. So awesome. Well, thank you, everybody. We're kind of right on time. Look at that. That never happens with us.
Nicely done.
So awesome. Well, thank you, everybody out there, for joining. I know some had to jump off probably because it's 5 o'clock on the East Coast. Definitely thank you again, Walt, Paige, Randy, and Chris. You guys have been awesome. And well, I guess the next time we're going to be doing the Power Hour down in Austin, Texas. And as you guys know how I end these, till next time, rock on.
Rock on.
See ya.
Here, everyone.
See you. Bye now.